Happy Thursday, chemistry students, or whatever day you're watching this. Let's talk about entropy and Gibbs free energy, or in other words, let's talk about some chaos. All right, so first, let's talk about enthalpy. It's a term we've heard before, and we've represented it with a delta H, which means the change in heat. This represents stored energy. And if we want to talk about nature, or what we expect to see in a chemical system, is that our reactions are going to tend towards low energy. So reacting so that the products have lower energy than the reactants. I like to think of it as Mother Nature being lazy. It is easier to keep things in a low energy state. So we can think of ice to water. That releases energy. Water is a lower energy state than the ice is. Now our new concept for today is entropy, represented as a change in S, or the order of the system. This is the amount of disorder or chaos, or how disorderly the particles are in a chemical reaction. Nature favors high disorder. That means to keep the molecules in a compound orderly takes a lot of energy. It is easier, so to speak, to keep things in a more disordered state. That means that things tend to go from less disorder or more orderly to more disordered or less orderly. In other words, something with low entropy would be our solids. Those particles are very organized, and it takes energy to have them in that state. And we go all the way to our high entropy or high disorder or high chaos, and that's going to be our gaseous particles moving everywhere, collisions, very little attraction between them. And so nature is going to tend towards things being in a gaseous energy to maintain things in a solid state. I like to think of our bedrooms. Many of us probably don't fight nature, and our bedrooms tend towards a disorderly or high entropy state. So when we take these two concepts, that of enthalpy, the energy of a system, and entropy, the chaos or disorder of a system, and we look at the temperature, that allows us to talk about Gibbs free energy, or in other words, quantifying how likely a reaction is to occur. So we can add that in. Delta G tells us, will a reaction be spontaneous? Spontaneous meaning without any additional input of energy, will this reaction occur? So when we calculate Gibbs free energy, or delta G, using the formula the enthalpy, delta H, minus the temperature times the entropy, if we get a positive value for delta G, that tells us the reaction will not be spontaneous. That means for this reaction to occur, there's going to need to be an additional input of energy or a change in the temperature to make it happen. If delta G is a negative number, the reaction will be spontaneous. No additional energy is needed at that temperature. This reaction will occur. If you happen to get an answer of 0, that tells us that this reaction is at equilibrium. Equilibrium means that when a reversible reaction is occurring, we have no overall change in the quantity of reactants and products. It doesn't mean the reaction is happening, but the overall quantity stays the same, or the ratio of reactants to products is unchanged. All right, so let's practice calculating Gibbs free energy and assessing what that means. So we have this reaction. Ammonia chloride yields ammonia and hydrochloric acid, and we have the enthalpy, which is a positive 176 kilojoules per mole. Where entropy is 0.285 kilojoules per mole Kelvin. The temperature is 25 degrees Celsius, and we want to know if the reaction will happen. Now, if you notice, entropy is in Kelvin, which means temperature also needs to be in Kelvin. So 25 degrees Celsius plus 273 gets us 298 Kelvin. So our formula, Gibbs free energy, delta G, is equal to the enthalpy, a positive 176 kilojoules per mole, minus the temperature in Kelvin, 298, times the entropy, 0.285 kilojoules over mole Kelvin. Now, you know, I always encourage you to keep your units when you plug into a formula because that allows you to see where units cancel. For example, those Kelvin cancel, so that kilojoules per mole minus kilojoules per mole, we're able to subtract those. All right, plugging this into my calculator, 176 minus, and then in parentheses, so your calculator gets the order of operations right, 298 times 0.285, you're going to get with let's see, we got two different sig fig rules. So 298 times 0.285, we're going to have 3 sig figs, goes right to the decimal, and then 176 to the decimal. So our answer is going to be 91 kilojoules per mole. So what do we do with this number? Well, if we look back at our chart, if it's a positive number, the reaction will not be spontaneous. So what we can include in part of our answer is if Gibbs energy is 91 kilojoules per mole, then this reaction will not occur spontaneously because it is a positive number. And so there's our answer. For the reaction of ammonia chloride decomposing into ammonia and hydrochloric acid, that is not a spontaneous reaction. That would not happen on its own. You would be required to add additional energy or change the temperature to make it happen. All right, here's a second example. I recommend that you pause the video now and attempt calculating the Gibbs free energy if we change the temperature of our reaction to 402 degrees Celsius and determine whether that reaction will occur. Pause the video now. Okay, let's check your answer. So our enthalpy is the same. Our temperature has increased. We need to change that to Kelvin as well. 402 degrees Celsius is 675 Kelvin. We're adding 273. Plugging into our formula, Gibbs free energy is equal to the enthalpy, 176 kilojoules per mole, minus the temperature, 675, times the entropy, 285 kilojoules per mole Kelvin. Kelvins cancel. And now from this, we get a negative 16 kilojoules per mole. If we go back and reference our chart, you'll see that when delta G is negative, that means the reaction is spontaneous. So yes, this reaction will occur. So what we can see is that by changing the temperature, we've created a situation in which this reaction now is favorable for occurring on its own. All right, that's it for Gibbs free energy. Go ahead and try working on 10.5. When you're done with that, check the answer key video. Thanks and have a great day.